Okay, sir. Recording has started. We will proceed. Sir, regarding the sluggish behavior I was teaching, isn't it, sir? Okay, sir. One thing, say for example, see, for a battery, suppose you want 14.5 volt as the charging voltage. Generally, for automobile batteries, 14.5 volt means good charging. See, suppose you are setting this value 14.5 volt and you are connecting it to the battery leads. You know that battery is rated for 12 volt. Yes. Sir, the lead acid battery is 12 volt. Bike up to this thing 7 ton, up to 7 ton commercial vehicles. No, it is only 12 volt. When you go for above 710, 10 tons capacity, 20 ton capacity, only for those vehicles you will have the 24 volt system. Otherwise, the 12 volt system is only popular. So, what I was telling, yes, sir. See, I was telling about 12 volt. No, so when you connect 14.1 volt charger, this is the charger. See, when you connect the 14.1 volt charger, what will this 12 volt battery do? It will not immediately reach 14.1 volt. No, it will take some time. That is called a lagging period. That is the reason for this sluggish behavior. So, battery, suppose if it is discharged, it will be in say it is in 11.5 volt. Slowly, with respect to time, slowly only it will charge. Not suddenly it will reach 14.1 volt. Do you agree with this, sir? What I am saying?
Yes.
Any battery, when you connect it to the charger, if the charger voltage is 14.1 volt, immediately the battery will not go to 14.1 volt. It will retain its state, or it will maintain its voltage level. Before charging, if it is 11.5 volt, when you connect the charger, slowly it will rise. It will start to rise slowly.
What is
Just a minute, sir. So I told it is slowly rising. No, if it is only resistor, it will not rise slowly. Can you get the point? If you have only resistor, here this one I was about C1 I'm speaking. No, sir. If you add only R1 in a resistive circuit, that slow charging will not happen. If you have only resistor, the charging will be instantaneous. Can you get the point? If the battery behaves like a resistor, immediately this 12 volt should become 14.1 volt. No. That's why I'm going to the basic thing I'm explaining you. If you represent this battery as a resistor, if the battery only, if you resistor R1 alone, if you consider, immediately this should go to 14.1 volt. It is a capacitor. Capacitor means it is a time delayed circuit. So R1 plus C1 both are there. So that is the cause for the slow charging. Is it clear? Yeah, sir, if you have doubt you should ask. Otherwise, in the same part I will say one or 2 points, then I will go to the next part.
what actually how come just because of resistor the battery will charge what does capacitor?
Sir, the battery behavior, the slow charging, it is due to the chemical property of the battery. So why the battery is sluggish? Because the chemical components inside the battery are like that. Sir, when we switch on the bulb, immediately once you put the switch, the bulb is glowing. It is the nature of the bulb. The battery is sluggish means it is the nature of the battery. Lithium ion battery or lead acid battery or any battery, based upon its chemical component, it is sluggish. Is it clear? To represent the sluggish behavior, we are modeling it by R and C, R1 and C1.
Okay, so instead of chemicals, we are using resistors and capacitors.
The behavior of the battery, it is modeled by R1 and C1.
Okay.
Sir, at this stage, one more idea I will tell you about modeling. I was telling, no. See, here anything you can keep in the model. It is not a rule. You should only keep R1 and C1. Anything which will represent the behavior of the battery. So in that analog, we found that C1 and R1, that adding a capacitor in parallel to R1, this is able to represent the behavior of the battery. This is established by experiments. They have confirmed that this equivalent circuit is able to represent the behavior of the battery. Is it clear, sir?
Like experimentally.
Yes. See what they do, no. Here they will give one input. See, one input they will supply here. This they will pass through this input is passed into the battery. Say input I'm blindly fixing 16 volt I want to pass into the battery and see what is happening. Sir, real life you can have 16 volt. If you insert 16 volt upon this battery, something will happen, no? The same thing this model should also do. If I have a model like this, here we are having V, no? Here I will insert and see in real life how it is behaving, what is the current flowing. Same thing should happen here also. That is, then only this model is working properly. Is it clear? And now that these technologies are established for each and every battery, sir, and one more at this point, one more thing I will tell you. See, sir, this equivalent circuit model, it is not only for lithium-ion battery. The same concept can hold good for lead acid or other type of batteries also. Then how it differs? This value C1, R1, these values only will change. The model will remain the same. Almost for about 50% of the types of batteries, you can use the same model. The
Values of capacitors and resistors.
only that will change, sir. And again, one more point I will tell. Then I will go to the next slide because I should complete the class, no, sir. If you want to do, I was telling about the parasitic capacitance. If it is lead acid battery, the same model you can take and you can insert a block to represent the parasitic capacitance. The basic block will remain the same. Additionally, one more block that should be added to represent the parasitic capacitance. Is it clear? Sir, you are from Kerala, no?
No, actually,
Where your place, sir? Your
Maharashtra.
Maharashtra, very good. Sir, actually, what happened no in my area when the Enfield Bullet, maybe during my childhood, maybe some I think some 30 years back, Enfield Bullet was very popular. What these people thought no, Enfield Bullet, if you put stand in the ground from the battery, that time you remember, sir, it will have a steel box, something like that, green color bullet. The box will be green in color. Do you remember that?
No, actually, green, I have never seen green bullet. Some classic and all that.
Only latest model you have seen, huh? Okay, okay.
Latest, like
Okay,
5, 6
okay,
years old.
okay, okay, okay. Sir, in old bullets, there will be a battery box. What we people, our people thought no, when the bullet was introduced, when we put the stand is metal no, from the battery, the current will, the mechanic also told like that, from the battery box, the current will go to the, through the stand, it will go to the ground. And so what we should do no, always that bullet we should put stand upon the mat. We should put on mat, upon that mat only you should put stand, otherwise your battery will drain. That way and all, many many mythological ideas are there. So why I am giving this interesting event, what happened no, actually some amount of self discharge will be there. There is nothing wrong upon the people. A small amount of
Capacitive resistance.
parasitic capacitance, just now I told no.
Parasitic resistance.
Parasitic capacitance, a small amount of self discharge.
I mean, battery like exact that would not remain the same, right? That happens in weak resistance.
Ah, a small amount of self discharge will happen, sir. Self discharge only in lead acid battery. In lithium ion battery, even that will not happen. Again, you by putting a mat below the bullet, that way and all, you cannot stop the self discharge. Can you get the point? Anyway, it is the inherent capability of the battery. But what the mechanic in our area no, they spreaded this news. So whoever was having that bullet, they were carrying a mat in their house, and upon the mat only they will put the stand. This is called self discharge. By how it happens no, within the battery itself. From the battery, within the battery itself, the discharge will happen. Small currents within the battery itself, it will circulate. Here within the battery itself, it will circulate, not going outside. That is called self discharge from one plate to another. Here within the cell, what is happening, that is called self discharge. So okay, sir, I will come back to this point. See here, self discharge and all we have not included in this model. Suppose you want to work for lead acid battery, you can add that self discharge. And in the same model, if you want to work about the aging of battery, due to aging what is happening, if you want to include, that can also be added. Sir, now that one important part is completed in our work, what is the model we are going to use for our study, that we have showed here. This is the electrical part of the model. Is it clear, sir?
Yes.
There are only two parts in our work. One is the electrical part, the other one is the mechanical part. Mechanical block, it is readily available. So just the heat dissipation, and again it depends upon the electrical part. So how much current flows. So here I have given now, sir, IM. Can you see in this block, sir? IM.
Yes.
IM is the current flowing in the battery. So how much, the more the current flows, the more will be the heat generated. Charging as well as discharging. How much current you supply, that will cause the heat. Sir, at this time I should introduce one new the formula, basic formula. How much temperature is produced? Sir, temperature, how much temperature is produced or how much heat is produced, it is based upon I square R. R is the internal resistance of the battery. I can be charging or discharging current. Is it clear? Hello.